Have you ever looked up at the night sky and wondered what's out there? I mean, what's really out there, lurking in the dark? We see the friendly, familiar lights of stars and planets. They are our cosmic neighbors. But what if something uninvited came to visit? Imagine a giant dark wanderer, a planet with no sun, hurtling through the blackness of space. Now picture this rogue planet dragging a long, wispy tail behind it, like a ghostly comet. And what if our little blue Earth, on its journey around the sun, was about to fly right through that tail? It's a mind-boggling thought, isn't it? A true great moment in science, or perhaps a great moment of cosmic panic. So, let's play a game of what if. So what exactly is this rogue planet we're talking about? Well, think about our own solar system. We have 8 planets, including our Earth, and they all circle around a star, our sun. They are like a family, held together by the sun's gravity. A rogue planet is a planet that doesn't have a family. It's a cosmic orphan. It doesn't orbit a star. Instead, it wanders all alone through the vast, empty darkness between the stars. How does a planet go rogue? Sometimes a planet can get too close to a much bigger planet, like a Jupiter. The big planet's powerful gravity can act like a giant slingshot, flinging the smaller planet right out of the solar system. Another way a rogue planet can be born is if its home star dies. Some stars end their lives in a massive explosion called a supernova. This explosion is so powerful it can blast the star's planets away, sending them hurtling into space. Scientists believe there could be billions or even trillions of these rogue planets in our galaxy alone. But because they don't have a star to light them up, they are incredibly hard to see. They are the lonely wanderers of our galaxy. Now let's talk about the tail. When you hear the word tail in space, you probably think of a comet. A rogue planet's tail would be very different from a comet's. One possibility is that the tail is leftover debris from the planet's birth. When the planet was violently ejected from its home system, it might have dragged some rubble with it. Another idea is that the tail is collected during its journey. As the rogue planet travels through the galaxy for billions of years, its gravity would act like a cosmic vacuum cleaner, sucking up material from the thin soup of gas and dust between stars. So, a rogue planet's tail could be a mix of things: fine dust like smoke, tiny crystals of water ice, and even some gravel-sized rocks. It wouldn't be thick and dense, but incredibly thin, far thinner than the air we breathe. So, what's the first thing we would notice if Earth flew through this ghostly tail? The show would start high up in our atmosphere. Even a tiny speck of dust would hit our atmosphere with incredible energy, like a microscopic bullet hitting a wall. Now, imagine not just one particle, but trillions upon trillions of them, all hitting the atmosphere at the same time all over the world. Our night sky would erupt into the most spectacular meteor shower in human history. It wouldn't be a few shooting stars per hour. It would be a constant shimmering rain of light, a sky literally on fire with meteors. This light show wouldn't be limited to the night side of Earth. The larger particles would create incredibly bright fireballs, brilliant streaks of light, brighter than the full moon, possibly ending with a loud sonic boom that could be heard on the ground. Every person on Earth would be able to look up and see that something extraordinary was happening. For days or even weeks, our planet would be caught in this celestial fireworks display. While we are all mesmerized by the light show in the sky, a more serious change would be happening to the air we breathe. The constant bombardment of particles would start to mess with the delicate balance of our atmosphere. As trillions of particles burn up, they would turn into gas and fine smoke, mixing with our upper atmosphere. The intense heat could break apart stable nitrogen and oxygen molecules, forming new compounds like nitrogen oxides. This would affect our planet's most important shield, the ozone layer. The chemical reactions could destroy ozone molecules faster than they can be replaced, letting more dangerous ultraviolet radiation reach the ground. All the extra dust would act like a fine veil in the upper atmosphere, blocking sunlight for months or years. The sky might look permanently hazy, and days might be noticeably less bright, an effect known as global dimming. With less sunlight reaching the ground, Earth's average temperature would begin to drop. This wouldn't be a dramatic instant ice age, but a gradual cooling that could disrupt weather patterns worldwide. Some regions might experience longer, colder winters, while others could see droughts or floods. Farming and agriculture would be hit hard as growing seasons change. Our fleet of satellites would be in the direct line of fire. Flying through dense streams of particles would be like sandblasting them. We could lose hundreds of satellites, causing massive disruption to global technological infrastructure. The intense fireballs could generate powerful electrical currents in the atmosphere, potentially causing widespread blackouts. We might find ourselves without electricity, GPS, and internet. How would life on Earth cope with all these changes? For humans, the initial spectacle would give way to serious long-term challenges. The health risks from increased UV radiation and changes in air quality would be major concerns. For plants and animals, the world would become a stranger place. The reduction in sunlight would affect photosynthesis, slowing plant growth and affecting entire ecosystems from the bottom up. The increased UV radiation would be particularly damaging to ocean life. Plankton, which form the base of the marine food web, are very sensitive to UV light. A collapse in plankton populations would impact everything from small fish to giant whales. The world wouldn't end in a flash, but it would be a slow, grinding process of adaptation to a new normal. Life is resilient, but such rapid change would cause stress on the web of life. Now, after hearing about all this potential doom and gloom, you might be feeling a little nervous. So it's time for some good news. The chances of Earth actually passing through a rogue planet's tail are incredibly, fantastically, astronomically small. The first reason is simple. Space is big, really big. The distances between stars are vast and empty. A rogue planet is a tiny speck in that enormous void. Even if a rogue planet were heading our way, we would likely have a lot of warning. New observatories are designed to survey the entire visible sky and would spot something as large as a planet coming from interstellar space. So, while it's a brilliant thought experiment to explore what could happen, it's not a realistic threat we need to plan for. The story of the rogue planet's tail is more of a galactic ghost story. So, what have we learned from our imaginary journey through a rogue planet's tail? We've learned that our planet, our home, is both incredibly resilient and surprisingly fragile. This thought experiment highlights how interconnected everything is. The dust between stars, the air we breathe, the technology we use, and the health of every living thing on the planet. For billions of years, Earth has been on a relatively safe path around our sun. This stability has allowed life to emerge, evolve, and flourish into the incredible diversity we see today. These cosmic what-ifs are not meant to scare us. They are meant to inspire curiosity and wonder. They push us to learn more about our universe and our place in it. Ultimately, the story of the rogue planet reminds us of one simple truth. We have only one Earth. It is our lonely blue marble in the vast, dark sea of space. We must study, protect, and cherish this remarkable planet. It's the only home we have, and it's the most wonderful and amazing place in the known universe. And that is a great moment in science.